I'm going to explain how the solar oven works. So, in the solar oven, the light energy from the sunlight is transferred into heat energy. The suns emit energy in the form of electromagnetic radiation. When the electromagnetic radiation comes into contact with an object, the energy from the radiation excites the molecule within the object, and objects start to heat up. So in this solar oven, the reflector aluminium foil will reflect the sunlight into the chamber. So once the chamber become warmer than the surrounding air, the heat attempt to escape from the chamber. But since the oven was closed with PVC rigid barrier, this the heat remained trapped inside the oven. Then the temperature rise rapidly, which will enable the oven to cook the food inside. So next, the main component for solar oven to work is the reflector, the aluminium foil, and then the PVC rigid sheet, which the retention to prevent heat escaping to outside, and also the aluminium inside to make sure the heat to radiate the electromagnetic radiation.
Now I want to justify our significant step in designing oven. First, why we use polystyrene? We use polystyrene for the base of the oven as the insulator to prevent the heat escape from the oven. And we also use cotton wool between the inside of the cardboard and also the outside of the cardboard as the insulation for our oven. And to make the whole body and the reflector, we use cardboard. To maximize the light input, we shape it into the hexagon shape, and it will make our design different from other design, because it is the first time we use the shape of it. We use this shape. Usually we can see is shape of square. So it is a new one and a new invention to use a hexagon shape. The fourth is I want to explain about aluminium. We use the aluminium as the reflector and the inner side of the oven because we want to maximize the light input from the sunlight. We also use the PVC rigid sheet as the top of the oven because we want to prevent heat from escaping into surrounding environment. So I think that's all from my explanation and justify why we make this design like this. Oh, I forget something, which is we always use sellotape to join the cardboard. So to make the cardboard more strength and not easy to break, we also use the close tape to combine between the cardboard, or to combine all the cardboard together to make this shape. So when we put it under the sunlight, it will be still same like this shape.
Next is our suggestion step to improve our solar oven. We adjust the angle of direction of the solar oven at which the sun radiation strike the earth's surface so that the cooking chamber is directly facing toward the sun. The angle of direction plays an important role to maximize the absorption of sun energy and concentrate the sun ray into the cooking chamber. which means the more the absorption of sun ray and concentrate the sun ray toward the food, the greater the energy heat capacity will be from the sun converted ray, which means the heat energy rate will be more because of the absorption of sun ray is maximized.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farhan and I will explain question number 4, which is, does your solar oven works? Please test your solar oven and discuss the result. So I will explain the step on how we handle this experiment. So there are varieties of shape and method on how to increase the efficiency of the solar oven. After we do some research, we decide to choose a hexagon shape of solar oven because hexagon shape can trap more heat energy, since the hexagon shape have many sides that help to increase the reflection of light and also the heat. Okay, so so I give a space a little bit. So this is the video on how we handle this experiment. So the first step is we need to put the raw egg inside the aluminum seal container, as you can see like in this video. Then we will observe the condition of the raw egg for each 15 minutes, and also we will record the time consumed for the egg to be fully cooked. Okay, next we put the aluminum container containing raw egg inside the solar oven. Then we close the oven using the PVC rigid sheets. So the purpose we close with the PVC rigid sheet is to ensure that the heat is trapped in the oven for a long time. Okay, so this is the result after an hour of observation. As you can see at the bottom of PVC rigid sheets, there are water vapor showing that the oven is hot, and also you can see a small white patch at the white egg, showing that the egg is partially cooked. So the oven can't fully cook the egg because we can't gain enough heat to cook the egg due to the weather, and the weather is windy at that time. So we decide to try again in the next day. So this is the result for the next day. As you can see from the video, the egg is fully cooked and the egg is a little bit hard, maybe because it exposed to the surrounding for too long. And also I have provided some footage of our hexagon solar oven. So that's all from me. I will pass to the next presenter. Thank you.
Next, as for the conclusion, the purpose or the objective of the experiment was to construct solar oven using the listed material and measure how effectively solar oven work to absorb energy from the sunlight, and yes, we had achieved the objective by doing it. Solar oven has its own advantages as solar oven use sun energy to cook food. This means we don't have to use gas or electricity, which save our money and better for the environment. But the solar oven can't be used at night. We also use the material that has been listed before, and the step in designing the oven also had been explained before. I also will summarize the discussion as the material had been used has its own functioning. For example, aluminum foil is used for the light reflection, while the cotton ball for insulator, and lastly PVC rigid sheet was used as retention to prevent heat escaping. As what being learned, the solar oven was not that efficient to use compared to the kitchen oven, as being affected by some factors such as weather. That's why the egg in the first test was not cooked very well, because the weather is about to rain. And we also have create the relationship for the temperature and the time. The low energy absorbed from the sunlight by the oven cause the low temperature of the solar oven, thus the longer time taken to cook. So that's all from me. Thank you.